Jacob Helmus, represent the gold team. My other team members are Jimbo and Vladimir, and I'm going to be going over the wash station response characteristics. A little bit of overview of the overview. We'll go over the background, look over the schematic, look at both block diagrams for the steady state and step diagram. We'll give you the operating curve, and I'm going to go over how you find the gain, dead time, and time constants, give you the results of each one of our tests, and then wrap it up at conclusions. A little bit of background. This system resembles the POTW sewage treatment plant, Chattanooga. Pretty much they use this system to wash out filters which become clogged with sludge, and then they take this sludge and they get rid of it in the dump or wherever it may be. There are 3 wash stations. 2 of them are controlled by valves which allow you to either run 1, 2, or 3 stations. They're supplied with between 7 to 10 pounds per minute of water, and our job is to determine the relationship between the flow rate and the speed of the pump motor. This is a schematic of the wash system. You see here, water is pumped, it goes through this system, and you see the 2 valves here which allow you to either run whatever number of stations you need to, and in our case both valves are open. This is the flow control, which the flow rate transmitter reads the flow rate, and then which then tells the controller to tell the actuator whether to speed up, slow down, or to remain the same. So block diagram, we have the input power going into the system, which then gives us an output of pounds per minute, and the only control variable is the input power. Okay, this is a sample of our system ran at 60% input. This, you can see that it spikes up and then begins to go steady state. And from this one, we concluded that the average is 12.1 pounds per minute with a standard deviation of 0.8 pounds per minute. Then through all the tests, we ran at 0. We did steps of 10. We ran at 0 to 100 steps of 10. And we found that before 45% input power, it was too unstable to conclude a steady state curve. And above 90, it was also way too unstable to map that on the steady state curve. And we found that the function is 0.28 of the input minus 4.9. Now this is showing that we're going to do a step response, which the input power is going to either step up or decrease, in which in our test we did 15% increase and decreases. This is an example of one of our step responses, stepping from 45 to 60. And then the next step we took was to find the change of C, which is the change of the output. And we did this by finding the longest range of steady state and taking the average of that and then plotting a line for that average to find your change in C. And in this part, we found that the gain, which is change of C over the change of the input, is to be 0.34 pounds per minute per percent. This is the overall gain results. You can see that the overall average of our system is a little less than 0.3 pounds per minute per percent. Now this is a sample of how we found the dead time. We did this by drawing a line to best fit the step, and then where this line intersected with the lower output value from the time that it changed, the input is our dead time, and we found that to be 0.5 for this example. These are all of our overall dead time results. From this, you can see that we average a little bit more than 0.5 seconds of dead time. Here's a sample how we go about finding the time constant, and this is using the FIT2 way to find this. You take 62.3% of the of the change of the output, and in this case we found that to be 3.2. But then you then add that to your lower value, and we found that it's about 10.5. And then from where the line intersects the step line, we find that change from the end of the dead time to this point is a time constant. In this case, it's 1.2 seconds. Here's the overall of all the experiments we ran. And from this, we found an average of 1 second dead time. These are the overall results. We found that, now keep in mind that it ran from 45 to 90%, and the output ran from 17 to 19 pounds per minute. Our average gain was about 0.3 pounds per minute per percent, with less than 0.05 uncertainty. The dead time was about half a second, and the time constant was right at 1 second. And on conclusion, steady-state operating curve fit the function of C equals 0.28 of the input minus 4.9, and of course our average gain, dead time, and time constants.